Go.
Hi, we are the Rambot Senior Design team. So with our team, we are actually an extension of EC Outreach. And with that, we are trying to produce an educational tool in which we're able to show off how interdisciplinary projects come about in industry. So our team consists of 3 electrical, 3 computer, and 2 mechanical engineers. With this, we are also trying to make a way to make robotics more accessible. Currently, as it is, the industry is pretty expensive to get into. There's a lot of roadblocks when it comes to educational background and all that sort of thing. So what we're attempting to do is create and make a reproducible quadrupedal robot. And with this, we've actually come across a lot of different developments. We've had a lot of different struggles. And this is actually the 2nd year of our team. So with this, we actually received all of the components on a table provided for us. And what we have done is actually assembled it, connected all the pieces, and we encountered a few roadblocks along the way. So as one of the computer engineers on the team, a big part of it is going to be that software. So if you take a look down here, we do have 2 microcontrollers powering the entire thing. We first have that Raspberry Pi. It's completely Python code. Raspberry Pi is going to be doing all of our multi-threading, so it's handling our controller input from a PlayStation 4 or DualShock 4 controller, alongside our machine learning and any other control inputs that we added. And then our TZ 4.1 is an Arduino, so it's using a modified version of Arduino C++. And it's actually going to be doing all of the math for us. So the controller is going to send input to the Raspberry Pi. The Raspberry Pi then sends that to the TZ. The TZ then makes the math occur, and then sends angles out to each of the motors, telling the motors how to move each of their joints to occur and move into a various math system. So of course, this project, we are interdisciplinary, so we've got a lot of things going on here. Power and communication made up a good majority of this project as well. I mentioned some of the communication already, but for power, we do have 2 giant LiPo batteries on the undercarriage of our robot. Powering everything, you can actually see some of our power sensors right here, monitoring what we're at for the power of our batteries. We do have some extras. Of course, we're able to swap them out. That moves us over to the more mech territory per se for hardware. One of the largest roadblocks and struggles we had as a team was the actual motor controllers here. These motor controllers are essentially a translator. They take our code and translate it so the motors know how to move. So the ones that we inherited, we found to be actually faulty. We had a lot of issues with them, and with that, we spent I want to say 2 to 4 months actually trying to compare the motor controllers, trying to figure out what was wrong, thinking it was our fault. We learned a great valuable lesson there that you should always test components before using them. It's important to know if your components are faulty before putting them into anything. And of course, with this, we decided in the end to end up replacing them. So we actually went from O drives to O desks. It's just a different brand of motor controller. And with that, we did have to redesign a lot of our rib cage here in order to support the new shape of the board we are using. And we found a lot of success with that. Another one of the roadblocks we encountered was going to be the wiring and the soldering. We had a lot of bad soldering joints, a lot of connectivity issues. And because of the volume of the number of wires we have here, we had a lot of noise coming from our wires, which is why you'll see some of these cables are actually braided to help prevent some of that noise that's occurring. For the future works of this project, there's still a long ways to go. This is just the 2nd year, and so we're hoping to integrate more of that machine learning aspect we inherited from last year into the actual control of the robot, and produce a fetch mode or a follow me mode. So do you want to demo it? So currently it's on walk mode, so you can go ahead and see we've got that triangular movement with each of the feet, and what you're seeing, which is also emphasized in the poster, but each of the toes acts as an endpoint and creates a triangular movement that illustrates our walking motion. Thank you so much.